Hello.
Hi parents, this is teacher David Ng. Today we will be moving on to quadratic equations, the real-life application of quadratic equations in real-life context and functions in real-life context. So without further ado, let me go straight to the contents where I'll be showing you real-life examples of quadratic equation. This is part of the syllabus for IP Year 3 or Sec 3 Emax. So let's say you have a triangle. Okay, let's say the owner. Okay, let's say Peter wish to build a fence along the perimeter of his field. Okay, on a map with scale of 1 to 3,000. Okay, the piece of the field is in the shape of a right angle triangle with sides x cm by 2x plus 3 cm and x plus 7 cm. Okay, establish the quadratic equation in terms of x and solve this quadratic equation then after that暂时这样子先哦。Okay, he wished to build a fence along the perimeter of his field. So this is the perimeter of his field. I mean, this is the size, the plan of his field. Scale of 1 to 3,000. Field is in a shape of right angle triangle with sides x. Okay, xcm by x plus 7. X plus 7 followed by 2x plus 3. Okay, so the quadratic equation, right? Since this is a right angle triangle, right? Okay, since this is a right angle triangle, right? Therefore, by Pythagoras theorem, Okay, by Pythagoras theorem, right? 2x plus 3 square equal to x square plus x plus 7 square. Okay? Agree? You agree with this statement, this equation?
Yes.
Because of Pythagoras theorem, the hypotenuse, the length of the hypotenuse, if I square it, would then be the other two sides, right? X square and x plus 7 in a bracket square. So the next step is you expand everything. 2ab, 4, 3, 12. Two AB. Okay, you end up with this. So this one I bring over, right? Okay, 9 minus 49. Okay, 9 minus 49. So minus 40. 12 minus 14. So minus 2. Okay, you end up with this. Then they say establish quadratic equation, established already. Then I suppose you solve this quadratic equation, right? So you solve this quadratic equation. Let me see, I can factorize it. 5, 4. 5, 4.
Yeah.
Confirm is 5, 4. No other way. 5 times 4 is 20. But I want minus 20, right? So one of them is minus. So which one is minus? Then you see, I want negative x, right? Negative x, right? Negative x is negative 5x plus 4x. Okay, negative 5x plus 4x. So negative x. Positive 4 times negative 5, negative 20. So this is the factor for this quadratic equation. Then they ask you to solve, right? So when you solve, okay, x plus 4 is 0 or x minus 5 is 0. Okay, either minus 4 or 5. Okay, then usually this kind of question, right? They have a part, they'll ask you to explain why one of the solutions must be rejected. Okay. Hence, find the actual length in meters of the fence needed. Okay. Then after that, what is the area of the field? Okay, what is the area of the field? Okay, this is the question. The full question. Okay, this is a full question. So we are halfway there. You are at explain why one of the solution is rejected. So which one you think you should reject?
The one with negative.
Negative 4 you reject. Okay. How come? They ask you to explain also more.
Because the triangle, the side must be greater than 0.
Yeah, because x is length. Okay, because x is physical length. And physical length cannot be less than 0. Okay, physical length cannot be less than 0. Okay, that's the reason. Explain already why it's rejected. Explain. Hence, find actual length of the meters, right? Okay, actual length of the fence required, right? So 2x plus 3. Okay, probably a better way would be actual length, right? Okay, actual length would be 2x plus 3 plus x plus 7. Okay, that's the actual length, right? 2x, 3x, 4x. 3, 7, 10. Okay, 4x plus 10. So since x is 5, therefore actual length equal to 4 bracket 5 plus 10. Okay, 4 bracket 5, 20. 20 plus 10, 30. Okay, actual length 30 meters. Not 30 meters, you don't know. 30 cm. How come 30 cm? Because 30 cm is on the map. But they want actual length, right? Then the scale 1 to 3,000, right? So be careful. 1 to 3,000, actual length, now it's talking about length. So since I'm talking about length, right, I don't need to square it, right? Because it's not about area. Correct or not? Correct.
Correct.
About length more. Parameter is length. So right now, the length, right, the parameter on the map is 30 cm, right? So 30, 1 is 3,000, right? So 30 is 30 times 3,000. Okay, 90,000. 3 times 30 is 90. Then add 3 0. So the actual length is 90,000 cm. Cm. 90,000 cm, right? Okay, then you got to write here. Okay, change to meter. They want answer in what meters? 900 meters. Okay, actual length of fence, right? Okay, 900 meters. So exam, be careful. I nearly want to write 30 cm or 30 meters. Then I forget about the scales. Then I read the question again, right? I realize I need to convert to the actual length by using the scale. So in exam, right, when you finish the question already, right, you want to move on, right? Just before you move on, please read the question one more time. That is what I did earlier. That's how I realized, oh, it's not 30 cm. I got to change to this. Okay. Because I practice what I teach you. That's why I remember the scale. You know, I completely forget about the scale already, to be frank. Okay, if not, I will move on to area already. I'm going to move on to area already. Once I got 30 cm, I'm happy. I think that's the actual length, that's the answer. Then I move on and find area already. to be frank with you. Then I practice the principle of what I taught you to read the question before you move on. So I read one more time, right? Then I read here, scale, then actual area, actual length. Then I realize, in meters. Then I realize I got to do this. Okay, in exam, please read the question at least one more time before you move on.
Okay.
Okay, now they ask you, right, area of the field. Field, not the map, field, area of the field. Okay, area of the field, okay, area on the map, right? Area on the map, okay, area of field on map, area of the field on the map, right? Half base times height, right?
Mm.
So 5, x is 5, 5 plus 7 is 12. Okay, area of the field, right? 30 cm square. Okay, the length and the area same. First time I see. So area of the field on the map, 30 cm square. Okay, I'm going to erase here because I need the space. Okay, I erase here. And I still need the scale, so I keep it here first. Okay, I have the area of the field on the map, right? So the scale is 1 to 3000. Okay, that means 1 cm, right? Correct, 1 cm, 3000 cm. Then cm square. Okay,
Okay.
3 times 3, 9. How many 0? 6 0. Mm. 30 cm square, right? And 30 lah. Then 6 0. Okay, don't forget this is still in cm square. So the actual area of the field is this. That's the actual area of the field. But I want to convert it to meter square, right? I want to convert this to meter square, right? Okay, 1 meter, 100 cm. 1 meter square, right? Understand?
Understand.
100 times 100. So 1 meter square is 10,000 cm square. Now I have this cm square, right? So I'm going to divide by 10,000. Two, 4, 7 0. Okay, 7 0. 4 0. Cancel my 4 0. 27,000 meter square. Okay? Understand?
Understand.
So that's the area of the field. Okay, so that's one real life example.
Okay.
Okay, I still got other example. Okay, other example. Other example, right? Okay, another example, right? Okay, John travels from, okay, John travels 320 km from Johor to Thailand. Okay, example. Using his car. The average, the average speed of, okay. He didn't use his car. He traveled from Johor to Thailand, the average speed of of his car is 20 km per hour more than the average speed of a coach. Probably change to bus. Okay.
Okay.
Okay. If average speed of bus is x km per hour, find an expression in terms of x for the number of hours John would take to reach Thailand if he uses his car. If he chooses to if he uses his car he will reach Thailand or he reach Thailand okay 1 hour 45 minutes earlier. Find a quadratic equation that represent all this information. Okay. Okay. Solve this quadratic equation and find the time taken by John to travel to Thailand in a car and also in a bus. That's the question. Ready up? Okay, John traveled 320 km from, what happened? Okay, John traveled 320 km from Johor to Thailand. Average speed of his car, 20 km more than average speed of a bus. So average speed of bus, okay, average speed of bus is X. Okay, average speed of car, 20 more than bus, right? Okay, average speed of car 20 km more than 20 km per hour more than speed of bus. Then they give you bus is X, right? So you have the average speed of car in terms of X. Find expression in terms of X for the number of hours John take to reach Thailand. So hours taken, right? Hours taken for car. Okay, the hours taken for car. 320 divided by this. Okay, distance divided by speed give you the time. Okay? Agree on? Expression in terms of X for hours taken to reach Thailand, he uses car. Thailand and Johor 320 km away, then car speed, distance divided by average car speed, you have time taken to reach Thailand. Okay, then how about the time taken, right? Okay, car is this out. Bus would be different, right? Bus would be okay, this bus. Then they say that if he used his car, he reached Thailand faster, right? So since reach Thailand faster by 1 hour 45 minutes if using car. Okay, so you have this equation now. Okay, this is the time taken by the car, right? Car is faster, right? Car is faster. Car is faster means means the time is less. Correct or not? Car faster means time is less, right? Okay, car is faster means less time. So bus more time. Faster by how long? 1 hour, 45 minutes. Okay, 45 minutes is 3/4. So 1 3/4 hour. 1 3/4 hour is 7/4. Okay.
Okay.
Okay, 1 whole plus 3/4. 4 plus 3. Okay, that's how I get this. 7/4. Because this is in hour, so I have to change the 45 minutes to 3/4 hour. Then I have this expression. Okay. Find quadratic equation, right? So I haven't found my quadratic equation yet. I'm going to find that quadratic equation. So find expression in terms of x for number of hours John take to reach Thailand if he uses car. This is the expression. Okay, so now I'm doing this part. This part is the find quadratic equation. Find quadratic equation. So I'm going to combine these two together. Yeah, I'm going to combine these two together. Okay. Combine together means this part I'm going to multiply by this. Correct? For the numerator. You understand?
Understand.
320 times 20 32 times 2, 64. 1020. Okay? 320 times this. 320 times this. Understand how I get this?
Understand.
4 times 6400. 4 times 6400. 4 times 6400. Use calculator. 256. 25600. 25600. I'm going to write here 7x squared plus 7 times 2, 14. 140 x. Understand? I skip a lot of steps.
I understand.
You understand what I'm doing? You understand how I jump from here to here? Okay, maybe I share the detail. How come I can skip so many steps? What was going through my head? Because no more space to write. Okay, this one, okay. 320 minus 320. The x disappear for numerator. So 6400 cross multiply, right? 6400 times 4 is this. 7x. 7x multiplied by this, right? 7x times x, 7x squared. 7x times 20, 140x. That's how I get this. Okay? Then after that, everything divided by 7. Okay, this one you can't really divide by 7. Okay, never mind. I'll still stick to 7x squared. Okay, you end up with this equation. So find quadratic equation. Okay, I found my quadratic equation. Okay. Then solve this quadratic equation. Solve this quadratic equation. Okay, ask calculator. Okay, here you can ask calculator. 0.40 square minus is plus, right? So plus 28 times 25600. Okay, 4 times 7, 28 lah. Minus you have plus. You have 736400. So I square root this guy, right? I have 858.1375. Okay, so I have two answers, right, for x. So you find both. So your x is 51. Okay, 51.3. If I minus, right? Yeah, negative 71. Okay, negative 71 or 51. So you have to reject this negative one. The reason is because, right, x is the average speed of bus. Speed of bus cannot be negative. Make sense?
Makes sense.
Yeah. So you got to reject this negative. So you have to put here not applicable. Okay, not applicable. So I'm using this as the answer for x. Then solve already. Okay, time taken by John to travel to Thailand in car and in bus. Okay, if I have the speed of the bus, I have the speed of the car. So bus is 51.3. Car would be 71.3. Okay, at 20 lah. So I have the speed of both, right? I can find the time taken already, right? Since I have the distance to travel. Okay, so time taken, right? Time taken using car. 320 over 71.3. Okay, hours are 4.48 hours. Okay, 4.488, 4.49 hours. Okay, they said time taken, right? You write 4.49 hours, or you can change it to 4 hours. 4 hours, 29 minutes. So when they ask for time, right, they usually ask to state it in terms of hours or in hours and minutes or in minutes. So you just change accordingly. So time taken, if I use bus, right, 51.3. 6.23 hours. 8 hours. 6 hours. 6 hours, 14 minutes. Oh, any question? No question, any y'all?
No.
This one quite straightforward. Right? Just flying. The concept we have learned. Okay, another word example. Another one. Okay, Ali threw a ball into the air. So imagine you throw something up in the air, right? If you throw something up in the air, you'll come down, right? Because of gravity. So imagine Ali is here. You throw the ball. You hold the ball. You throw the ball up into the air. You throw up, you'll come down. Right? So the ball you throw up, come down. Throw up, come down. Quadratic equation, no? Can see? Can see this quadratic equation?
And
The pathway taken by the ball is a quadratic curve. Right? So you see the real life application. The pathway taken by the ball is a quadratic curve. Okay, the path of the ball can be modeled by a quadratic equation. Okay, the quadratic equation will be h equal to negative t squared plus 3t plus 2, where t is in seconds. Okay, where t is in seconds and is the time, from the moment the ball is thrown, and h in meters is the height of the ball. Is the height between the ball and the ground. Okay, the height between the ball and the ground at any moment in time when the ball is in the air. Okay, then they ask so. Find the highest point where find the difference in height. Between the ball at its highest point and the where Ali is. Okay, Understand the question now? Okay. Okay, Ali threw a ball in the air. He threw a ball in the air. Okay, Ali could be here. Threw a ball in the air. Okay, how do I know that the curve cuts the y-axis? If you look at this equation, right, there's a +2. So this is 2. Okay, that's how I know you cut the y-axis. Okay. Okay. Okay, T is in second, Y is in meters. H is in meters, I mean. Okay, H is the height between the ball and the ground. Okay, instead of writing where Ali is, right, and ground level. Okay, and ground level. Because where Ali is quite vague. Where Ali is, you got to account for the height of Ali also. So they want to find difference in height. Difference in height between the ball at highest point, which is here, right? And ground level. This is the ground level. So they want you to find turning point. Correct? Turning point, right?
Mm.
Okay, turning point. So you complete the square. So complete the square. Okay, let me do here. Here got more space. Okay, first you need to know what they ask you to find. They're asking me to find turning point. How do I know it's turning point? Because the way it's described, the difference in height between the ball at its highest point and ground level. Turning point already. So at this point, then I know my H mark. So then after that means I complete a square in order to know my turning point. Here I take out negative. Okay.
Okay.
Okay, -2 -9/4. A square -2ab plus b square. A minus b bracket square. -2 -9/4. 2 is 8/4. So -8 -9. Okay, -8 -9 is -17. Then I put back my negative sign. Okay, this is my completed square version now. But they're asking for the height, right? The height is 17/4. Okay, difference in height is 17/4. And the time, the time when it is at the highest point. Okay, when this bracket is 0, t is 3/2 second. H is 17/4 meter. So the difference in height between the ball and the ground level is 17/4 meter. Okay, difference in height would be okay, 4.25 meter. Sometimes the question will ask and the time when this happened. Okay, time at 1.5 seconds. Okay, at 1.5 seconds, the ball would reach the maximum point, the highest point. Any question?
No.
No question. If no question, right, you can try the question in the book now. Hi guys, this is teacher David. Okay, I'll continue with the last question for this presentation. So my last question is here, right here. Okay, the last question is a question that I've come across. It's very interesting. Okay, it says that during a flight, okay, an airplane flies from her land to Green City and back to her land. The distance between her land and Green City is 400 kilometers, and the total time taken for the whole journey is 5 hours. Given that there is a constant wind blowing from her land to Green City, and that the speed of the aeroplane in still air is 150 kilometers per hour. Find the speed of the wind. And state any assumptions made. To solve this problem. Okay, this is the question. Okay, so this is the question. It says that during a flight, an aeroplane fly from Pearland. So let's say this is Pearland. Okay, this is Pearland. Aeroplane flying from Pearland to Green City. Okay, aeroplane flying from Pearland to Green City, then back to Pearland, right? So airplane flying from Pearland to Green City, then back to Pearland. Distance between Pearland and Green City is 400 km. So the distance between Pearland and Green City is fixed. Total time taken for the aeroplane to fly from Pearland to Green City and back from Green City back to Pearland is 5 hours. Okay, given that constant wind blowing from Pearland to Green City, so there's a wind blowing, right? So wind blowing Pearland to Green City. So imagine if there's a wind blowing, right? The plane actually travel faster, right? Correct or not? The plane travel faster, right? If you go from Pearland to Green City. And when come back that time, it actually goes slower because the wind is going against the aeroplane. Okay, so if the wind blow from Pearland to Green City, that is what happens. Okay, the speed of the aeroplane is 150 km per hour. Okay, speed of aeroplane, right? Okay, in still air. Okay, that is the speed of aeroplane in still air. So if the speed of the wind, right? Okay, you're going to find the speed of the wind, right? So you're going to let speed of the wind. Okay, you're going to let the speed of the wind be x kilometers per hour. So the time, the speed, so the actual speed that the aeroplane is traveling, right? Actual speed. Okay, the actual speed of aeroplane, right? Okay, Pearland to Green City.
Miles.
Okay, the actual speed of the aeroplane from Pearland to Green City, right, would be 150 plus x. Because the aeroplane traveled from Pearland to Green City, right, in this speed, this is the speed of the aeroplane still, right? Then you need to plus the speed of the wind, because the wind blow from Pearland to Green City. So I need to add x now. That's the actual speed of the aeroplane. Okay, then when you come back, right, actual speed of aeroplane when Green City to Pearland. Okay, when you come back, the wind is going against the aeroplane, right? So I need to minus off the speed of the wind. Okay, so now you have the speed, right, of how the plane is going to travel, right? So you're supposed to find formulate an equation, a quadratic equation, or an equation that, based on the information given, you're supposed to formulate an equation and solve for your x. So the time taken for the whole journey, right? Okay, probably before I write total time is 5 hours, right? Okay, let me write out the time taken. Time taken for the plane
1, 2, 3, 4,
to travel
5.
from the time taken for the plane to travel from Pearland to Green City. Okay, time taken for plane to travel from Pearland to Green City, right? 400 divided by the speed of the plane, right? The distance divided by the speed of the actual speed of the plane, Pearland to Green City. So that's the time taken. How about the time taken when you travel back to Pearland?
Let X seriously.
Okay, Green City back to Pearland, right? 400 divided by 150 minus x. Okay, because 150 minus x is the speed of the aeroplane when it travel from Green City back to Pearland. So the distance been unchanged, right? So distance divided by the speed of the aeroplane, you have the time taken in hours. So I have the time for the whole journey now, right? To and fro, and it's 5 hours, right? So since time taken, right? Okay, time taken for the whole journey, right? To and fro is 5 hours, right? So I just add together the time taken for both. And that would be equal to 5 hours. So I just need to solve this equation to find my x. And after finding my x, I would have solved this problem by finding the speed of the wind. So I'm going to multiply, right? Okay, if you notice this equation, right, 400. Okay, probably I would erase this part so that I have space to do the question. So this is the equation I'm supposed to do.
That cool, seriously?
Okay.
One, two, three, four, five, six, seven, eight, nine.
Okay, so this is the equation I'm supposed to solve. So to solve this equation, I'm going to multiply every term by this expression. Okay, I'm going to multiply every term by this expression. Okay, then this multiplied by this expression, right? It's actually 400 multiplied by this expression plus 400 multiplied by this expression. Okay, because I'll cancel one of this when I multiply by this.
All black suit Spider-Man information.
Okay, 150 plus x, I cancel away, right? So it'll be 400 multiplied by 150 minus x. So this one, when I multiply by this, I cancel off 150 minus x. So I end up with 400 multiplied by 150 plus x. Then after that, I open this bracket, 400 multiplied by 150, you have 60,000.
And what?
Okay, a plus b, a minus b. That is a square. A square is 150 square. 150 square minus x square. Okay, a plus b, a minus b, a square minus b square. So 225, 0 times 5. You have 1125, 0 minus 5x squared. Then this one minus 400x plus 400x. 400x disappear. This is 12. 6 plus 6 is 12. Okay. Then plus 40 behind. Or rather 60 plus 60 is 120,000. Then I'll bring this over, 5x squared over. This will be 1125, 0 minus 120. Okay, you have 5x squared.
5 miles.
Then you divide by 5. Okay, this question, right? If you notice, you can't really solve this problem. The reason is because, right, when you square, you shouldn't have a negative. That means, right, I would need to change the answer here, right? Instead of 150 km per hour, right? I would need to change this to some other value so that it holds water. Okay, so instead of 150, right, let me change it to 200. Okay, if I change it to 200, right, it will make sense. So if I have to change the speed of the aircraft to 200 in still air, right, whatever that was 150, I need to change to 200. Okay, it's the same concept. So whatever that's 150, I change to 200. The 400 is still the 400. Then after that, I just need to change this answer. Whatever is 150, I change to 200. Okay, then after that, this part, I would need to redo this part here. Okay, so I need to redo this part. Okay, because this question, right, I created it on the spot lah. So I never really do the calculation before I present to you. I create this question on the spot when I present to you. So I hope you don't mind. So okay, let's continue doing the question, right? The concept is still the same. It's just that I changed the 150 to 200. So 400 times 200, right? 4 times 2 is 8. Okay, 20, 20, 40. Okay, minus 400x plus 8. 4 times 2, 8. 80,000 plus 400x. So 5 bracket a square minus b square, right? Okay, this is my a square. 2 times 2 is 4. So there are 4 zeros. A square minus b square. So 400x disappear. 8 plus 8 is 16. 40. 5 times 4, 20. 40. So your 5x square, 5x square I bring over, positive x square. 20 minus 16 is 4, and 40 behind. Okay, 20 minus 16 is 4, and 40 behind. So x squared would then be 40 divided by 5 is 8, 8,000. So x would then be square root 8,000. Square root 5, 89.44. Okay, because x is the wind, right, blowing from Furland to Principe. So negative value is not applicable. Because x is the speed of the wind. So speed of wind would then be 89.44 km per hour. Okay, what's the assumption you make? The assumption you make is the aeroplane, right, did not stop at Green City, but fly straight back to per length when it reaches green city. That's the assumption you make. Okay, the assumption made. Okay, the aeroplane did not stop at green city. But flew straight back to Pearland
Ooh, my favorite.
when it reaches green city. Okay, that means the aeroplane, right? Pearland to green city, they didn't stop, fly straight back to Pearland. Okay, that's the assumption you make. Because it did stop, right? The time will not be 5 hours. The time will be 5 hours plus the time he stopped at green city. So I hope you understand this question now. Okay, that's all for this question. So hi guys, if you enjoy my lesson and if you like to learn more about AMAX and EMAX or even primary school max for PSLE, you can subscribe to my YouTube channel so that you could receive notification whenever I upload the new videos. So thanks for watching my videos. Do like and subscribe, hit the subscribe button at the bottom left side so that you could receive notification whenever I upload a new video. Thanks so much for watching. So I see you again in my next video. Bye bye.